Hi, I'm Jasmine Kwasa. I'm a postdoc in the Neuroscience Institute at Carnegie Mellon University in Pittsburgh.
And I'm Etienne, a research associate in electrical and computer engineering at Carnegie Mellon University. And we're here to talk to you about racially and phenotypically inclusive EEG and fNIRS.
Thanks for having us. But first of all, some disclosures. I receive salary from Precision Neuroscopics, which is an inclusive EEG company, and we do talk about their products. And Arnell also has previously received salary from them as well. A lot of what we're talking about today comes from two articles that we wrote recently. Arnell, the first one from Neuron, Building a Culture of Responsible Neurotech, and me, Nature Neuroscience, Addressing Racial and Phenotypic Bias in Human Neural Methods. And the latter paper outlines 3 eras of neurotechnology development that we'll go through. The first is very short, a history of racism in medicine. We'll spend the majority of the time talking about the era that we believe that we're in now, which is an era of ignorance, and then the era of negligence, which is what we would like to avoid in the future. And then we'll finally end with a little bit about what you all can do to help and some resources, including our inclusive EEG handbook. In the history of neuroimaging development, we started with electrodermal recordings. In the 1920s, 1930s, EEG came around, and then it wasn't really even until the late 80s where the beginning of fNIRS and different light-based technologies were developed. But under the surface, in medicine, there are actually these horrors related to how Black people or marginalized people are treated in the medical enterprise. So you all might be familiar with many of these. I won't go through all of them, but I'll just highlight in 1845, before slavery was even abolished, James Marion Sims, known as the father of gynecology, did experimental surgery on enslaved women without anesthesia. This is a horror. Similarly, in 1932, Tuskegee Institute refused treatment of syphilis on several Black men. So these are things that are known biases in the medical history that we have to contend with. And it wasn't really even until the year I was born, 1991, where protection of human subjects became federal policy. And even in 2020, we're still working on other sources of bias. And then even under the surface of that, the timeline of Black liberation tracks with this, right? So slavery wasn't abolished when Sims was working, and it wasn't really until the summer of 2020 when we started to reconsider kidney transplant scores in medicine and unbias them towards Black people. So all of this is connected, and no science that we do is ever in a vacuum. Okay, so the next era that we're going to talk about in depth is an era of ignorance. We currently are in an unusable data crisis, and we're using colorblind methods. What is colorblindness? It's the racial ideology that the best way to end discrimination is by treating individuals as equally as possible without regard to their actual identity. And the evidence shows that it actually tends to perpetuate racism because different groups of people have different needs. This is illustrated beautifully by a colleague of mine at UCLA, Achuta Kadambi, who wrote that there is physical bias, computational bias, and interpretation bias. We will focus here today on physical bias, or what I would call phenotypic bias, meaning that some of our hardware that we use for neuroscience research is biased against people with certain phenotypes, certain skin tones, hair types, et cetera. So I'll pass it off to Arnell to talk in particular about EEG, and that will be our prime example of an ignorant hardware that we use.
Electroencephalography, as it is used today, is standardized for hair that does not look like mine, does not look like Jasmine's, and does not look like a lot of patients out there. So Hans Berger, who was a Nazi-backed scientist, actually invented the first EEG in 1924. As you can see, they were not thinking about us when they created this technology. And so the currently accepted systems that we use in EEG don't work well on Black hair. On the left of the C, you can see a cap being used over someone's hair, but that does not take into account my hair needs. And on the right, you can see me using an EEG system that also does not adhere to the scalp, which is what you need to get better contact. So like we said, EEG is a century old, but it still doesn't help everybody. So just to understand a little bit more about why hair found commonly in people of African descent acts like a spring, which pushes against the electrode and interferes with scalp contact. It inhibits signal quality and then creates low quality data that can be rejected or can contribute to misinterpretation and misdiagnosis. Clinical EEG can take longer and be more traumatic for Black patients because technicians who might not have an understanding on how to treat our hair properly and how to use the strengths of our hair to help administer this important diagnostic test can create issues along that pipeline of diagnosis. And also, Black people are often excluded from clinical studies of EEG, which creates a data set that does not include our needs and thus makes it harder to generalize it ethically. So there's misdiagnosis, there's incomplete data, and it's just kind of a mess. Our solution was Sevo systems, and it's a way of installing electrodes that includes cornrowing, which is a way of braiding the hair, and using the Sevo electrode wings to install electrodes into the scalp. So as you can see on the figure on the left, we have the Sevo electrode wings, and on the top path, we have a gold cup adapter that we use in hospital spaces. And then on the bottom side, you can see the BioSemi Sevo adapter, which can be used in research spaces. And then on that right photo, we have hair cornrowed on the left using EEG sticker, and then on the right using the Sevo systems. And as you can see, it's easy to maintain contact with Sevo systems on the right because the hair is actually helping to push the electrode down. So in our paper in 2020, Novel Electrodes for Reliable EEG Reportings on Coarse and Curly Hair, we explore that paradigm of, cornrowing the hair, adding Sevo electrodes. And what we found was that Sevo electrodes with cornrowing performed 18 times better than current industry standards in coarse and curly hair, which is an incredible jump in signal quality. So we were able to go into the UPMC Children's Hospital with Dr. Christina Patterson and test on several children within the hospital. So in that middle picture, you can see one of our patients whose hair was actually already cornrowed, already braided, and we were able to use the Sevo system in her hair as it was without any manipulation, which was amazing to see. And she was able to be a lot more comfortable. Her mother was able to be more comfortable because she saw the care that we took in. So it's not just the science, it's also the way that we as scientists, technicians, and clinicians approach patients that makes a difference as well. And as you can see with our team, having a diverse group of people to solve a problem really works. We were able to bring all of our points of view, all of our knowledge that we have to create a cohesive solution that helps to allow patients to get the data, like we said, that they deserve.
Less emphasis on this, but we also had the same problems in fNIRS. Recently wrote an article describing this issue in functional near infrared spectroscopy. And the problem is not only that the hair is in the way of light penetrating into the scalp, but there's a layer of melanin as well. And so if you're unfamiliar with fNIRS, it's a light-based technology and it works better. The light can go through the scalp better on people with straighter hair, blonder, lighter hair, and lighter skin. So if you want more information about that, we don't have time to go into a deep dive, but that's in this article that came out a couple months ago. I'd also like to shout out that in fNIRS, our team is also very diverse. So CMU is really at the cutting edge of what we would call inclusive neurotech development. We have a big meta grant that we're working on, and we're even moving into sub-Saharan Africa to do further testing on the continent. Half the battle is cultural knowledge, not the novel devices. You could consider all sorts of aspects of hair that I won't get into, but I'll just point out that there's coarseness, there's density, there's springiness. There's a specific thing about Black hair, which is that it turns back or shrinks. So that's depicted down here. You can lay hair flat. You can apply some tensile strength to it. You could even straighten it. But as soon as it gets curly or as soon as it gets wet again, it might go back or shrink into its original style, right? And then there are additional concerns that everyone has, which is the length of the hair and then access to the scalp through different cultural practices. So I'm here to just let you know that there is bias throughout our medical and research enterprise in everyday life. And I just want to point out that it's kind of all around you. So this hair type bias is in EEG, it's in fNIRS, and it's in most electrical stimulation. That could be TACS, TDCS, et cetera. Skin color bias is true in fNIRS or any light-based technology. Anytime you're shining light, may it be for like a breast cancer screening, for example, there will be some melanin issue. Pulse ox is a big example of that. It went viral in the New England Journal of Medicine that pulse ox is biased against people with dark skin. And then even temperature readings, which is based on the same infrared spectroscopy. Fitbits and soap dispensers for my whole life have been not great. You know, I could get into the details of the technicals of it, but a lot of the commercial light-based technologies don't work as well on people with dark skin. And then finally, there's size and gender bias as well. So if you're dealing with pupillometry data, so seeing how big the eyes are, people with smaller eyes, and I'll just say it, you know, folks with Asian backgrounds tend to have lower quality data. And that's not that their eyes are wrong, it's that the hardware is not accommodating different phenotypes. Same thing with MRI boards, obesity, pregnancy. There are issues of people not being able to fit, and it's actually a loss of dignity because a lot of times those people will be sent to a zoo where they can accommodate larger bodies. And even seatbelts aren't friendly to pregnant women. So just these things are in your everyday life. And I just wanted to point that out. The last part of the article is avoiding an era of negligence. And we basically highlighted that a skin conductance recording modality that most people with darker skin tend to come back and their data was called unusable. But it turns out the reason why the data might be unusable is not just the dark skin, it's that there's discrimination in the world that leads to a brain difference. So for example, fear conditioning, amygdala activity is all involved when you're doing some type of electrodermal recording. And all of those things can confound your signal. So here you can see that racialized negative lived experiences affect the brain just as much as phenotypic bias might affect the device. And the result is that together, you know, a biased neural response and a biased device will equal data that we call bad or unusable, or make us label people as bad or difficult or non-responders, non-learners of whatever task we're doing. So that's a problem, and we will be negligent if we didn't recognize that there's a deeper reason for it. It's really about racism, not race. So there are all these oppressive practices that we don't think are racist, but because they don't actively include ideas about marginalized groups, it ends up being racist. Okay, so now let's add in, you know, the fact that we have these phenotypic biases, someone's wig clip, someone's acrylic nails, these things might get in the way of their pulse ox or their MRI, but there's also this issue of trauma. So I've added to hair type bias, skin color bias, and size, actual racial bias and cultural bias. And we see this all the time in MRI. Tattoos and piercings can't go in the scanner without certain preparations. And even for pulse ox, when you're putting light through a finger, your nail color or fake nails might get in the way, and people have created tools to circumvent that.
So what can you do as a researcher to make it more inclusive? So first, you have to remember that experimentation is sensitive in the Black and Brown community. We have trauma around medical spaces already. And also hair is very important to us and sensitive to us culturally. And then also prepare your participant. Let them know what the test entails. Let them know that they should detangle and stretch their hair before, and talk to them about the concept of wash day, which is something that we talk about in the Black community. You would want to schedule a test for right before wash day so that all the gunk is not an issue for them and they can just wash it out on that day that was already set aside for it. You can also use individual electrodes, and while you're marking, go slowly, because parting can be painful, but it's also the most important part of getting a clean signal, how you part. And then lastly, with cap setup, be patient, exfoliate the scalp while applying gel, and just again, inform your participant.
We also wanted to emphasize that there are a lot of resources online for this. So I just pulled up YouTube and typed in detangling and stretching. If you don't know what that means to people in the Black community, there's so many resources out there. So you can go and find advice, and you can even send that ahead of time to any participants or patients you have so that they're informed. So that's pretty much all we have today. Here's another really great resource for you. We created inclusiveneuro.com. There's a collection of us at Carnegie Mellon really trying to get the word out about these kind of cultural things beyond just the technical. And if you'd like, you can just use your phone and scan this QR code, but it's inclusiveneuro.com. And there's tons of resources there. It's under construction still, but there's already a lot of good information there. And that's all we have. Thank you so much for being here, for engaging us. And here are some of our acknowledgements. We, again, work for Precision Neuro, which is a company that sells these electrodes. We are members of the Grover Lab. Pulkit Grover is great at making sure that all ideas are valued. And of course, to our collaborators in the BME department at CMU, working on fNIRS, and to the UPMC Children's Hospital here in Pittsburgh for letting us use their resources. You can follow us on Twitter, and we're happy to take questions in the Twitterverse or via email as well. Here are references.
Thank you for having us.
Thank you.